Alrighty, so now we can proceed with the second part of our notes. So I remember the next part was about creating layers. Okay, now you know how to create layers. And then creating basically a ruler. I'll call it a ruler. Something that will assist you to measure your changes. No, not your chain. Something that will assist you to measure your natural ground levels accurately. Like when it's time to start plotting the points so that you can join them into a curve. So I came up with something like this. Let me just zoom it out, zoom it in, out, is it in or out? Let me just zoom. Hopefully you'll be able to see what I'm talking about. So remember our vertical spacing, the distance between our horizontal lines is 20, right? So now we need to come up with 10 equal spaces in between, something that will assist us to divide that into 10 equal segments so that when we plot the points, so when we plot our natural ground level points, we're able to put them at accurate points. Remember that where you're given your natural ground levels or your question paper, you are very seldomly given a whole number. Your values are often given as like 124.3 or 12 something point whatever. So this ruler, this thing that we are calling a ruler, will basically assist you to get the points, because remember that on our table we only have, let me just go back, we only have whole numbers, so we only have between 122 and 130. So basically that accuracy ruler will be stuff that we put in between. They'll assist us to get the points. Okay, so what you can do is you do your 20 divided by 10 and then you get 2 millimeters. So basically you can offset that at every 2 millimeters to end up with something like that from 0 to 9. Okay, then you can create a layer for this ruler on its own, so that when you're done using it, like when you're done plotting all your points, you can easily freeze it instead of deleting them one at a time, because remember, things get very congested in your graph when you're done plotting. Okay, so next you can just copy all the lines, all the internal lines, copy, and then use the first one as a base point, and then basically you can paste them here. Remember that they fall in the middle, and remember that you used your first line as a base point, so you paste it from there onwards. Okay, paste, 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 paste. There you go. Remember, you don't necessarily have to do this. This is just my way of making sure that my points are accurate and wherever I plot is the exact point, because you don't want to be guessing where the point will be, because then that changes the shape of your road, it changes the position of your points, and it affects so many other things, including your marks. Righty, once you have something like that, let me just minimize it a bit. Come on, don't call me. Okay, once you have something like that, the next step is basically calculating all the values that you will be entering on your table there, on or in your table. It's in lockdown. Okay, so next we'll need to calculate the grade, the tangent grade, the offset, the final road level, and then your cut or your fill. Okay, so remember on your slides and in your notes, you are given a set of formulas that you can use to carry out calculations pertaining to longitudinal sections. The first part is calculating your grade, your G1 and your G2, keeping in mind that you need to express your G1 and G2 in terms of percentages. Okay, so remember that the formula for your G1 is the level for your VPI minus the level at A divided by the chainage for the VPI minus the chainage at A. Okay, now I'm just gonna quickly go through this point because I'm guessing you guys have done the calculations. If you've submitted, I don't know what you submitted if you haven't done the calculations, but basically then for G1 you will have 125.4 minus 126.5 divided by 180 over 0. Then you end up with minus 6.111 times 10 to the power negative 3. And then when you need to express it as a percentage, you basically do that, divide by 1 times 100. So you end up with negative 0.611%. Okay, then for G2, similarly, you have a level C minus the level for the VPI divided by the chainage at C minus the chainage of the VPI. In terms of values, you have 124.8 minus 125.4 divided by 450 minus 180. You then get a value of negative 2.222 times 10 to the power negative 3. And then expressing that as a percentage, you have negative 2.222 times 10 to the power negative 3 divided by 1 times 100. You then end up with a value of negative 0.222%. Okay, now in order to represent your G1 and your G2 onto your table, so what you basically do is you take a dimension from Please allow me to take a dimension here. Gosh, what's going on? Okay, take a dimension from there, from the very beginning to your VPI. Okay, then you place it there, and then you take another dimension from your VPI to the very end, excuse me, and you place it there. Okay, now to clean it up, you can just trim command, trim, right click, and then you clean up everything here and here and here and these ones as well. So you end up with basically something that looks like that. Let's do this one as well because it looks nicer that way. Okay, then next is just editing the text here on your dimensions, because you remember you took a normal dimension from point A to point B, but now you want this specific dimension to represent your grade, your calculated grade. So now you double click on that and you basically want to enter the level there. Why is it not changing? Oh wow. Okay, let's try that again. Negative 0.611%. That's your G1, and then for G2 you will have negative 2.2. No, sorry, negative 0.222%. There you go. Then you can just edit them accordingly if you want to change the font size to make it bigger or smaller, but that's basically how you go about the grade row. Okay. All right, so the next row we have is our tangent grade. So that is basically the TG, and we also have formulas for calculating the tangent grade as given in your notes. So it reads as the tangent grade is equals to your previous tangent grade plus your grade multiplied by your chainage divided by 100. Okay, so now which formula you use will depend on where you are on your table. So if you're starting from the first chainage up to VPI, you basically use the previous tangent grade plus G1 times the chainage divided by 100. And then once you pass your VPI, you will use G2 instead of G1, but everything else remains the same on the formula. Okay. So the first tangent grade, you take it as the first final road level as it's given. Remember, we're given a final road level at A of 126.5, so that will be your very first tangent grade level. So you fill it in there as 126.5. That will also correspond with the final road level there as it's given. Okay. Then next, you basically calculate your each next tangent level to correspond with the previous one. So you need to make sure need to make extra sure that your answers are correct before moving on, because once you make a mistake somewhere here, then it basically messes up the rest of your table. Okay. So since we already have the first tangent grade level, calculation the second one will basically be this 126.5 plus into negative 0.611 times 30 divided by 100, and then you get a value which probably has more than 3 decimal places. Okay, so the trick I need to tell you here about your tangent grade is when you are doing your calculations, like when you are punching stuff into your calculator, you punch in the full number as it appears or as it was given in your previous answer. So for example, the answer I get here is 126.3167. okay. Now, when using that answer to get the next tangent level, I'll use it as it is as 126.3167 in the calculator. But when I'm entering the values here in the table, make sure that you enter your values to 2 decimal places. So normally what I do is I have a full page of calculations where I'm calculating my tangent grades. I'll calculate them in full and write down all the full answers as I get them. And then I go back to the very first answer, and then now I take my rounded off values to fill in here in the table. Because if you use rounded off values to do your calculations, chances are by the time you get to your VPI or by the time you get to your final level here at C, your answers won't correspond. Okay. So it's not even another method, it's just a secondary check to check if you're on the right track. Remember, you were given the level for your VPI and you're also given a level for your final level at C. If you want to check that you're on the right track, as you're calculating your tangent grades, when you get to your VPI here, the answer you get should correspond with the given level for your VPI. And similarly, when you get to your final level here at C, the answer you calculate should correspond with the value you were given initially when you started the question. So that is the way in which I check if I'm on the right track. So remember that your tangent grade is the previous answer you got plus the chainage, plus the grade times the chainage divided by 100. And then you get your value. So like I said, a trick that I use is basically to have a full page of calculations, and then when I'm done calculating, that's when I go back and take the rounded off values so that I can fill them in on the table here. Right, so I think you guys should be able to do the tangent grade. Let me see what could be confusing here. Okay, you guys need to pay special attention to the distances in between. Remember that this formula says it's the previous tangent grade plus your grade times the chainage divided by 100. But bear in mind that this chainage won't always be 30, okay? So it's basically the distance between the previous chainage and the next one. But in instances where you've now gone from, okay, chainage 0 to 30 to 60 to 90 to 120, the chainage there will definitely be 30. Like the chainages that you use in the formula will definitely be 30. But when you need to move from 120 to 130, the distance there between the two is a 10. The distance is not 30. So just be careful when you get to positions like that one. Careful that you use 10 instead of 30, because then it will give you a wrong answer. Similarly, when you move from 130 and then you're moving to 150, now the difference is 20. So make sure you use the difference between the 2 points. Okay, don't get confused by the term chainage and assume that it means that you use a same standard value as you go on. Okay, so just make sure that with each new point, you consider the distance between that point and the previous one, and not just the fact that it says chainage and therefore you're going to use 30 or whatever the difference is. I think those are the main tricks when it comes to the tangent grade. Those are the main confusing points when it comes to the tangent grade. You just need to remember that the first value is given as the value of the final road level at A. You take it as it is, and then when you move on, you do your calculations using the full answers that you get in the calculator and not the rounded off values. But when you come to fill in your values here on the table, you'll be using the rounded off values instead, rounded off to 2 decimal places. And then you need to be careful that you take into account the distance between the 2 stations before you punch in your formula in the calculator, just to make sure that you have the correct distance in between the 2 stations. And then the last trick is to make sure that the answers you get the answers you calculate when you get to your VPI, as well as when you get to your last level C, need to correspond with the given levels. By that I mean the given final road levels. Remember, the VPI, you were given the level, so the answer you get needs to correspond with that. Similarly, the answer you get here when you calculate the tangent grade for C needs to correspond with the final road level given at C. Okay, so looking on screen, you'll see that I have just filled in my tangent grade level calculations. So it's basically calculations that I carried out, and then once I was done with all the calculations, and then I filled them into the table, making sure that I was working to 2 decimal places. Yeah, 2 decimal places. Right. Then the next step is to calculate your offset distances, which is your y. So your y, we're also given a formula of ax squared over 200L. That is a standard formula. It's normally given on your formula sheet, but it's short enough for you to memorize it. Then your a is basically your g2 minus your g1. Then your x is the horizontal distance between a point and the BVC or the EVC, depending on which side of the VPI you are. So basically, where you take your x will be dependent on which side of the VPI you're working on. So if you're still on the side from chainage 0 to the VPI, you will consider the distance between that specific point and BVC. But as soon as you cross over to the other side, then you'll then consider the distance between that point and EVC. Okay. You need to bear in mind that the offset distance will only be applicable between your BVC and your EVC. In so saying, the offset distances before your BVC will all be 0, and the offset distances after your EVC will all be 0. So that means we will basically have a curve, a slight curve, somewhere between the beginning of your vertical curve and the end of your vertical curve. It's also a bit self-explanatory. It's telling you that you will basically have a curve between those 2 points. I'm not sure how else to explain it, but it basically explains itself. And then you need to bear in mind that, as I explained, your offset distances will be 0 before BVC and they'll be 0 after EVC. But you need to pay attention that your offset distance at BVC itself is 0, and similarly your offset distance at the EVC will also be 0. So whatever values you get are values that will go in between here, but on the points themselves, the offset distances will be 0. You just need to pay special attention to the chainages that you'll be working with between your BVC and your EVC, right? So like I said, to calculate your A, it's basically G2 minus G1, and it will be your negative 0.222 minus your negative 0.611. Then you end up with a value of 0.389. Okay, so now remember, your A is a value that you will plug into your Y formula, your offset distance formula. So now your formula reads as Y is equals to 0.389 x squared over 200 into 100. So that's the formula you'll be using to calculate your offsets in between these chainages over here. So remember, this first one will be 0 and this last one will be 0, and anything to the right or to the left of it will be 0. Now we'll be looking to calculate your offset distance here, here, and here. So you basically have 3 values for your offset distances. Okay, so now for this first one, your offset distance will be y is equals to 0.389 x squared over 200 into 100. But now I said, remember, x is the distance between that distance and the BVC or the EVC, depending on which side of the VPI you're working on. But since we're still on the left-hand side of the VPI, we'll be taking into consideration our BVC. So the y will basically be 0.389 into 20 squared over 200 over 100. So this 20 is basically the distance between this chainage and that. It's the distance between this point and the BVC. And then you get your value, you put it in there. The next point, which will be this one over here, the VPI, will basically be 0.389 into, now the distance between the VPI and that is 50. So it's this 30 plus this 20. It's the total distance between this point and the BVC. So it'll be 0.389 into 50 squared over 200 into 100. You get your answer, you plug it in there. Now, you need to pay attention to the fact that we just passed the VPI, which means we stop taking into consideration the BVC and we now consider the EVC. So the next point, to calculate your offset distance, you basically use 0.389 into the distance between this chainage here and the EVC, which is 20. You'd have 0.389 into 20 squared over 20 into 100. You get your value and you plug it in there. And then you have your, unplug it in there, sorry. And then you have your 3 offset distances and you're sorted. Alrighty, so if you take a look on screen, you'll see that I've just filled out my offset distances as per my calculations. And you just, let me just zoom this so you can maybe see better. You'll see that all the offset distances from chainage 0 up to where the BVC is were all 0, and similarly from the EVC all the way to the end was 0. So the only place that had values was basically in between the BVC and the EVC. So you'll realize that for our offset distances, we put in our answers to 3 decimal places. Reason being that our offset values are normally very small, so it's just an accuracy measure more than anything else to make sure that you don't miss any values, if I could put it that way. Okay. Then next we are going to calculate our final road level. No, don't call me. Okay. So our final road level, what are they gonna say? Oh, okay, our final road level, our first one, remember, it's given as 126.5. It was given on the question paper. Final road level for A was given as 126.5. The final road level for C was given as well. So now we are just basically going to calculate the final road levels for all the other chainages over here. Now, to calculate your final road level, it's basically your tangent grade plus your offset distance. Okay. Now you realize that your offset distance for most of these values here was 0. So this means that where your offset distance was 0, your final road level will be equal to your tangent grade, because it's basically your tangent grade plus your offset distance, which is 0, and then it gives you the same value there. So for these values here, your battery is low. The devil is a liar. Okay, let me just plug it in 2 minutes. Just start again. Okay. Alrighty, sorry about that, guys. So you'll be aware that these values over here, basically the values where the offset distance was equal to 0, will make your life 10 times easier. 10 times easier. Why do I have so many values over there? 10 times easier, because then you can simply just copy those values and then paste them over here where your final road levels are. Okay, so you'll see that I've just filled in my final road level values. Like I said, the ones that correspond with your offset values of 0 make your life easy, because you can simply just copy all these values, plug them over here, then come to the side, copy all these values, plug them over here. Okay, the only place where you'll need to basically calculate your final road level will be where these 3 chainages are concerned. But then again, that's very easy, because you simply say your tangent grade plus your offset distance, then you get your final road level. Okay, so tangent grade, offset distance, and then you get your final road level. Then the next step is to calculate your cut or fill. So that's basically your final road level minus your natural ground level. So this final road level, this row over here, final road level minus your natural ground level, it gives you your cut or fill over here. Alrighty, so okay, you'll see that I have calculated and filled in my values fill, my cut and fill, my cut being negative and my fill being positive. So basically you just enter all the values that you've calculated there, making sure that you enter the values to 2 decimal places, and then you are basically done filling out your table. Now the last part is filling out the graph component of your table. Remember that you've only filled out the values, but you haven't represented them. So now that's the last part that you need to do. And this is basically the easiest part really, because it's just plotting. It's like plotting a graph in maths or whichever subject you normally plot graphs in. Okay, so the first graph we need to show is basically the natural ground levels. Remember, you were given the NGL levels on your question paper. So like I said, what you do is the easiest way to go about it, I normally have like a circle command, something like that, a small circle, something that has a central node that will allow you to basically pick up the central point and paste it at a point and later join those central points together. You could always use any other command. You're not really restricted to using the circle command. I just find that it makes things easier, and it's easier to join the points together once you're done without wondering which is your central point. Okay, so you can go back to, what's this? Question paper. Okay, so here's our question paper. We'll basically plot the NGL levels as we go. All right, so you can see that for point change is 0. We have our NGL at 128. So I'll just show you how to do the first one, and then you guys can basically do the rest. Okay, copy. Then make sure you pick it up with the central point. If it does not snap with the central point, make sure you go back to your snap settings and make sure that your midpoint, center, or central node is enabled. And you basically pick it up there, remembering that your change 0 is this very first line. So you look for 128, make sure it coincides with 128 on the dot. There you have your first node. Okay, second point, 127.4. Okay, let me just zoom this out a bit because now it gets tricky. Okay, 127.4. You can copy this point, pick it up with the central point. This is 127, and it will correspond with this second node. Remember, it's on chain edge 30. Then you just move it upwards to get to 0.4. 127.1, 0.2, 0.3, 0.4. There. Just make sure you zoom to check if you're really on the right track. Okay, so you can just click on that to double check. 1, 2, 3, 4. Okay, cool. Third one, 127.7. Okay, similarly you can copy this, pick it up from the central point, 127.7, and it's the third chain edge. So this is 127. Okay, 1, 2, 3, 4, 5, 6. Wait. Move. 127. 1, 2, 3, 4, 5, 6, 7. There. Oh, I accidentally placed this one here. You can just delete it. Okay. So you see that now they give you basically points to where your natural ground levels are, and then you can basically place the rest of them in the same manner. Okay, so after you've placed all your nodes, you will basically join your central points using the spline command, using the first spline command, because the spline command has 2. So you basically use that first one here, and you will, join it from central point to central point of all your small circles, and then you end up with a curve that looks like that. So this curve basically represents your natural ground levels as they were given on your question paper. Okay, so make sure you use your spline command. Don't use the normal line command, because then it will give you straight lines, and the ground does not have straight lines like that. Okay. Then the next step, you basically repeat this exercise, but using the final road levels. Remember, you were given the final road level at A, and then you were given the VPI level, and then you were given the final road level at C. So what you basically do is connect those 3, but you start off by obviously drawing the small little circles that will show you where your points will be, and then you join those points using, this time you use a straight line. For the final road level, you use straight lines. So you basically have a straight line from point A to the VPI, and then another straight line from the VPI to the last point C. Remember, you have the final road level at A, at C, and then you're also given a level for the VPI. So you're basically joining those 3. Okay. Then last but not least, okay, let me zoom this in so you guys can see it clearer. The last point, the very basis of this whole exercise, the reason why you were doing this whole thing is to basically find a balance between your natural ground level and the final road level, and then represent a curve that will form in between the beginning of the vertical curve and the end of the vertical curve. So I'm not sure if you guys can see here, but there's a small curve over here that is basically formed between the 2 points that I just mentioned. So basically, after you've drawn your final road level, you will then use your offset distances to plot a curve. Yeah, you'll use your offset distances to plot a curve, remembering that your offset distance at the BVC is 0, and then the offset distance at the EVC is 0. So whatever values that you calculated in between here will basically formulate your distances. Then you will be able to basically plot them over there, and then draw a small curve using the spline command still, because I found that it works better with these kind of lines. And then you're basically done. You basically done. Yeah. Then to clean up your work, you can maybe just freeze your construction circles, and you can freeze your ruler, and then you end up with something like that. And there you have it. You have 4 marks, and just like that, you are ready for your exams. So if you have any questions, you know how to reach me by now. And yeah, hopefully this has shed some light.